Hello and welcome. Today we're going to be looking at WAEC 2019 Physics Past Question number 1. The time rate of increase in velocity is called A. Force, B. Momentum, C. Acceleration, D. Speed. So when we get the word the time rate of increase, simply means change in velocity with respect to time. So time rate simply means the ratio of a given quantity all over time. So that is what we are looking at. So this change in velocity over time, what is it? Is it force or momentum or acceleration or speed? Now, in order for us to understand this very well, we're going to take the definitions of all these one by one. So first of all, let's look at the first one, which is force. What is force? Force is defined as the product of mass and acceleration. So force is the product of mass and acceleration. So let's look at the second one, which is momentum. What is momentum? Momentum is simply defined as the product of mass and velocity. So momentum is the product of mass and velocity. Now let's look at the third one, acceleration. What is acceleration? Acceleration is simply the change in velocity or speed over time. And finally, let's look at speed. What is speed? Speed is simply the distance traveled all over time. So from all these, we can simply see that this is the same thing as the definition here. So that is acceleration, and that makes option C the correct answer. Please hit the subscribe button to subscribe to our channel. Always click the bell icon so that anytime we release any video, you'll be the first to see them. Thank you. Hello and welcome. Let's continue. Today we'll be looking at question number 2 for WAEC 2019 Physics Past Questions. Which of the following quantities is a vector quantity? A. Volume, B. Momentum, C. Energy, D. Speed. Now for us to understand this, we need to know what vector quantities are. And there are two major types of quantities that we have in physics. We have what we call the vector quantities, and we have what we call the scalar quantities. Now, what are the vector quantities? Vector quantities are quantities that have both size, which is magnitude, and direction. So vector quantities are those quantities that have size, and another word for size is magnitude, and they also have direction. Whereas scalar quantities are those quantities that have size, which is magnitude, but they don't have direction. So now let's look at examples of vector quantities. What are examples of vector quantities? Now, when we look at things like displacement, you know, we have distance and we have displacement. If you're traveling from A to B, that is distance. But if you're traveling A to B in a specific direction, say north or east, that is displacement. So displacement is a vector quantity because you can only say 20 meters north, or you can say 20 meters east. That is displacement, because you're showing the direction of the motion. But if it is distance, it does not have direction. Then distance is a scalar quantity. So under this example, we have distance. So we have displacement for vector, distance for scalar. Now another example is what we call velocity. Velocity is simply displacement over time. Whereas under here we have speed, which is distance over time. So you can see they are synonymous. The only difference here is that displacement and velocity has direction, whereas distance and speed have no direction. But they are all talking about the size of movement. Now, other examples of vectors are momentum. Why momentum is a vector is because for you to calculate momentum, it has to have element of velocity. So once you can have an element of something else, it's automatically that if that thing you're having its element is a vector, it's most likely that the quantity is going to be a vector quantity. So other quantities that are vectors are weight, because weight is normally towards the direction of the ground where you have the acceleration due to gravity. Another example is what we call acceleration. It's also an example of vector quantity. Whereas under scalar, other examples are things like volume. There's no direction. Speed, I've given speed before. Energy also, all these are scalar quantities. So from there you can simply see that the example that is a vector quantity here is momentum, and that makes B the answer. Please hit the subscribe button and click the bell icon. Thank you. Hello and welcome. Today we are going to be looking at WAEC 2019 physics past questions. Question number 3. In an elastic collision, momentum is conserved as well as A. velocity, B. kinetic energy, C. potential energy, D. speed. An elastic collision is a form of collision where there is no loss in kinetic energy. So whenever you have what we call elastic collision, it simply means a collision where there is no loss in kinetic energy. No loss in kinetic energy. That means the kinetic energy is conserved. That's the meaning of elastic collision. Any collision where there is no loss in kinetic energy. So there is no loss in both kinetic energy and momentum. So these two things are conserved. So any collision that has these two things conserved is known as an elastic collision. So momentum is already here. So the next thing here is B, which is kinetic energy. Please hit the subscribe button to subscribe on our channel. Click the bell icon so that anytime we release any video, you'll be the first to see them. Thank you and God bless you. Yes, let's continue with WAEC 2019 physics past question number 4. The induced current in a coil always flow in a direction so as to oppose the change that causes it. This statement is known as A. Coulomb's law, B. Lenz's law, C. Faraday's law, D. Ampere's law. So which of these scientists made this very statement that the induced current in a coil always flow in the direction so as to oppose the change that causes it? So for you to understand it, we are going to give the statements of these various people. So I'm going to start with Faraday's law. Faraday's law states that whenever there is change in magnetic lines of force, So whenever there is a change in magnetic lines of force or EMF, EMF is induced whenever there is change in magnetic force. Okay, let me state it very clear. So whenever there is change in magnetic lines, there is what we call EMF produced, and this induced EMF, the strength is proportional to the rate of change of the flux. So it's proportional to the rate of change of the flux. So that is Faraday's law. Now let's look at Lenz's law. Lenz's law states that the induced EMF, this very induced, the induced EMF moves in such a direction so as to oppose the motion of the change producing it. So it moves in such a direction so as to do what? Oppose the direction of the very change in flux producing it. So you can see that this is actually the statement that you're looking for. It's just the same thing. Now moving further, for us to understand other ones, talk about the Coulomb's law. The Coulomb's law simply states that the electrical force between two charged objects is directly proportional to the product of the quantity of charge on the object and inversely proportional to the square root of the separating distance. So we have that the force, electrical force, is directly proportional to the what? Charged objects. You understand? And also inversely proportional to the what? Distance, square root of the distance between them. So if you are combining it, you have F to be equal to K Q1 Q2 all over D2. So that is Coulomb's law. And finally, we'll talk about Ampere's law, which states that for any closed loop path, the sum of the length of elements times the magnetic field in the direction of the length of the element is equal to the permeability times the electric current enclosing the loop. So you have a statement that goes like this. So when there is a change, this is the formula that summarizes the statement of Ampere's law. So very importantly, this B here, or summation B, is the sum of the length element. The L here is equal to the magnetic field in the direction of the length of the element. Then this is the permeability, and finally I is the what? Electric current. So those are the various statements of the various laws. So when we are talking about Coulomb's law, we're talking about the relationship between the electrical force and the charges producing them, as well as the distance between the electrical force. When you're talking about Lenz's law, that's when you talk about the induced EMF or the induced current in the coil always flowing in a direction so as to oppose the change that is producing it. When you're talking about Faraday's law, you're talking about the EMF produced being directly proportional to the flux producing it and inversely proportional to the time. Then when you're talking about Ampere's law, we're talking about a closed loop where the sum of the length of the element times the magnetic field in the direction of the length element is equal to the permeability times the electric current closed in the loop. So the right option here is Lenz's law. So please hit the subscribe button if you like our videos. Always drop your comments in the comment section if you have any questions to ask. Thank you and God bless you. Hello and welcome. Let's look at WAEC 2019 Physics Past question number 5. Which of the following instruments can be used to compare the magnitude of charges on two given bodies? A. Electrophorus. B. Ebonite rod. C. Gold leaf electroscope. D. Proof plane. So for us to understand this, let's explain what these instruments are used. Electrophorus is a device that is used in transferring and storing charges. So that is what you use electrophorus to do. Ebonite rod is a device that you can use to make negative charge by rubbing a specialized vulcanized rubber with animal fur. So once you rub a rubber with animal fur, you produce negative charge using ebonite rod. Whereas proof planes are devices that can be used to safely transfer electrostatic charge. If you want to safely transfer electrostatic charge from one body to another, you use proof planes. So from one body to another, that's what you use proof planes for. But this very gold leaf electroscope is an instrument used for the detection and testing of small electric charge. So you could use it to detect and test electric charge, but it has to be small electric charge. So if you are drawing this very one, gold leaf electroscope, it has a structure like this. Here we have the brass disc, and it is then connected down here after having what we call the insulating plug. You have what we call the brass rod. You know, up there you have the brass disc, but here we have the brass rod. Here is what we call the metal case, and here is what we call the very gold leaf. And finally, you need to take charges to the ground. So this is what we call the gold leaf electroscope. The metal case, this very metal case in this gold leaf electroscope is normally connected to the earth. So we call it is earthed to prevent the accumulation of charges due to external influence. The leaf is the sensitive part of the instrument. This position shows the presence of charges in the discarded rod. So you can easily use it to compare the magnitude of charges in two bodies. So with that, we're going to pick C as the answer. So I want you to make research on this, and if you have any comment, drop it in the comment section. Let's look at it together. Thank you. Please hit the subscribe button and the bell icon. Hello and welcome. Let's look at this WAEC 2019 Physics Past question number 6. A body of mass 2 kg is released from a point 100 meters above the ground. Calculate its kinetic energy 80 meters from the point of release. A. 1600 joules. B. 900 joules. C. 600 joules. D. 200 joules. Now for us to understand it, we need to make this sketch. This body, say a ball like this, is released from here to the ground at a height of 100. Now you are told that this body has actually traveled up to 80 meters. Now, you are expected to find the kinetic energy when it has reached 80 meters, not the total 100 meters. So how do we calculate this? We all know that energy is conserved. Kinetic energy, potential energy is the same as the kinetic energy. So if you want to get the kinetic energy, we can just calculate the potential energy. So for this first instance, it's going to be m, which is mass. Mass we know is 2 kg, times g. Acceleration due to gravity is 10, times h, which is the height, which is 100 for this very one. So this is h. G is acceleration due to gravity, is always 10. And m is given to us as 2 kg. We can see it here. So if you calculate this, it's going to be 2 times 10, which is 20, times 100 is going to give us 2000 joules. So for this situation, at this point, what is the kinetic energy of the ball? It's going to be the distance from here to here. So what are we going to have? We're going to have m, still the same mh. So m is going to be 2 times g, which is 10, times the remaining height. What height is left? 20, which is 100 minus this 80. So if you multiply this out, you're going to have 2 times 10, 20 times another 20, we have 400. So we're going to have what is at this very point is going to be the energy here minus the energy in this instance, which is going to be 2000 minus 400, which will give us 1600 joules. And that is option A. Please hit the subscribe button if you like this. Give us thumbs up, drop comment in the comment section. Thank you and God bless you. Hello and welcome. Let's look at this WAEC 2019 physics past question number 7. Which of the following waves is not mechanical? A. Waves in pipes. B. Water waves. C. Radio waves. D. Sound waves. So which of them is not mechanical? Now there are two broad categories of waves. We have what we call the mechanical waves. That are waves that need medium for them to be transmitted. Then we have what we call electromagnetic waves, waves that don't need any medium for them to be transmitted. So mechanical waves are those waves that require material medium for their propagation. So once they require material medium, once a wave requires material medium, so they do what? They require material medium for propagation. So in order for them to be transmitted, they need what we call material wave. They need what we call material medium. So very good examples of these mechanical waves are water wave. It needs water for transmission. You have the sound wave. They cannot travel in vacuum. Then we have what we call waves in pipes and strings. Waves in pipes, strings, rope, all of them, they need a medium. Without that medium, like water or the surface, they cannot transmit. So all these, they cannot travel through vacuum. Because of that, all of them are known as mechanical waves. Then now let's look at electromagnetic waves. Here they do not require any material medium for them to be transmitted. They don't need it. So in other words, they can travel through vacuum. So what are examples of these waves? We'll talk about things like light waves. We'll talk about waves like radio waves. We'll talk about waves like X-rays. So you can see these ones, they travel through vacuum. This one requires a medium to travel. So anyone that requires a medium to travel, it is known as mechanical. The ones that don't require, that can travel through vacuum, they are regarded as electromagnetic waves. So from this you can simply see that the one that is not mechanical here, which is radio wave, is electromagnetic. So that makes option C the right answer. Please hit the subscribe button to subscribe to our channel. Thank you and God bless you. Hello and welcome. Let's look at WAEC 2019 physics past question number 8. A loaded spring is set in simple harmonic motion. The force that tends to restore the load to its equilibrium position is A. Adhesive, B. Elastic, C. Frictional, D. Gravitational. So which form of this force? If you have a spring like this and you load this spring with a mass, so if you tap this very string in this direction, it will go down and come up. So what is that force that is making it to go up and down, up and down? Is it adhesive force? Is it elastic force? Is it frictional force? Or is it gravitational force? Elastic material is one that regains its original shape or size after distortion, after the distorting force is removed. So this is the material. This spring is the very material that we are looking at. So if you distort it by pushing this weight down, it will come back. So that is what elastic materials do. So elastic materials, they do what? They regain their what? Shape and size after the removal of the distorting force. So whenever you remove the force that you're using to distort them, they will return back. So it's only elastic material that do that. When you talk about adhesive force, we talk about force of attraction between molecules of different kinds. So this is simply force of attraction between molecules of different kinds. So example is what we have between water and glass. When you put your water in the glass, they have this force of attraction known as adhesive force. Now frictional force is the force that opposes the motion between two surfaces in contact. So when you talk about frictional force, you're talking about force that opposes motion between two objects in contact. Then finally, gravitational force is actually the force of attraction exerted by a body on all other bodies in the universe. So that very force of attraction exerted by a body on other bodies in the universe, that is gravitational force. So from here you can easily see that the elastic force is actually the force, because it is the one that makes a spring to regain back its shape once you remove your hand after pushing this down. So that makes option B the right answer. Please hit the subscribe button. Thank you and God bless you. Welcome. Today we're going to be looking at WAEC 2019 Physics past question number 15. Which of the following graphs of change Q against potential difference V across capacitor is correct? A, we have this sketch. B, we have this sketch. C, we have this, and D, we have this. So the graph of Q, which is the quantity of charge against the potential difference, is supposed to be a direct proportional graph. So we are supposed to have Q varying directly as V, because the more the charge, the more the potential difference. So there is supposed to be a direct proportionality between Q and V. And in mathematics, when there is direct proportionality, we have this, because as Q is increasing, V is also increasing. So let's say we have Q as 1 here, V we are going to have as 1 if you trace it, and we have Q as 2 here, V we are going to have as 2. So this is what we call direct proportionality. If it was Q inversely proportional to V, we are supposed to have a graph of this nature, because as this one is increasing, let's say at 10, this other one is going to be at 1. So the right option from what we have here is B. This is direct proportionality, this is inverse proportionality, this is remaining constant, and this is not a straight line relationship. So with that, B is the answer to our question. Click the subscribe button to subscribe to our channel. Thank you and God bless you. Yes, let's continue with question number 29 of the WAEC 2019 Physics past question. Which of the following device is used for storing electric charges? A, transformer. B, ammeter. C, potentiometer. D, capacitor. So we're going to state the functions of these various electrical devices so that we can pick out the one that is used in storing charges. Now, a transformer is a device used in changing the size of an AC voltage. It increases or decreases the EMF of an alternating current. So this one is used to either increase or decrease EMF or voltage of an AC current or AC voltage. So that's what a transformer does. Now, what is an ammeter? Or let's get to potentiometer first. What does a potentiometer do? A potentiometer is a device used to precisely measure potential difference. So use this to measure potential difference. That's what you use this to do. It is used to compare EMF of a cell. You can also use it to compare EMF of cells. So that's what you use that for. Now, an ammeter is a device used to measure the amount of current flowing in a circuit. So use an ammeter to measure the amount of current flowing in a circuit. That's what we use an ammeter for. And finally, a capacitor is a device used in storing electric charges. So from there you can easily see that D is the right option, capacitor. Please hit the subscribe button, like and share our videos. Drop any comment if you have one. Let's look at WAEC 2019 physics past question number 33. Which property of waves travels from one medium to another? Which property of wave travel from one medium to another? A, amplitude, B, wavelength, C, velocity, D, frequency. Now let's define these various properties of waves so that we can know the one that fits the answer. Amplitude is the maximum displacement of a particle from its rest position. So whenever you talk about amplitude, we say it is the what? Maximum displacement of a particle from its rest. So from the rest position, that is what the amplitude is. Then wavelength, what is wavelength? Wavelength is the distance between the successive crest or trough of a wave. Distance between successive crest or trough. We are going to show this in a diagram so that you understand. Then what is velocity? Velocity is distance which the wave traveled in 1 second. So the distance traveled by the wave per second, that is velocity. Then frequency is the number of complete cycles. Number of complete cycles at a particular covered over a period. So number of complete cycle. So now we have the wave moving like this. So this is what we call the crest. These are the crest. The upper parts are the crest. The lower parts, they are known as the trough. So when we say distance between the successive crests is distance between here, this is the first crest to this other crest. So this is what we call wavelength. Now amplitude is distance from here to here. That is amplitude. Then what we call frequency is what is covered. A complete circle is here. This is half a circle and this is another circle. So when you cover a full circle like this, then you have the frequency. So now we can say that frequency never changes. However, other properties of the wave such as wavelength, velocity and amplitude can easily change. So you can actually have this amplitude changing when you're moving from one medium to the other. So you talk about moving from one medium to another. You can easily change the amplitude. You can also change the velocity and the wavelength. But this frequency actually remains. So it never changes. So when there is movement from one medium to another, the frequency remains. So that makes option D the right answer. Please hit the subscribe button. Thank you and God bless you.